Hi everyone, my name is Eren Gürbüz. I am a second year CS student at Bilkent University. Today we are going to conduct an experiment about the capacitance values of parallel plates due to varying factors. Let's introduce our equipments. Firstly, we have a digital multimeter with measure capacitance. We have alligator clips, and also we have parallel plates with distinct areas. Then we have three distinct materials to investigate the effect of dielectric constant, and lastly we have a ruler. In the first part of our experiment, we will use the same parallel plates in every trial, and we will firstly set the distance between the plates 3 centimeter and then increase the distance between them. And also in the second part of our experiment, we will fix the distance between them to 3 centimeters and use these distinct parallel plates. And also in the last part of our experiment, we will fix the distance between the plates again, and we will use the same plates every time and insert distinct materials to observe the effect of the electric constant. The wooden block 62 point approximately. Then we will insert the plastic block. Our value is 49.1. And lastly, we will insert a material from paper. Our capacitance value is 68.5 picofarad approximately.
In our first graph, we plotted the measured capacitance against the inverse of the separation distance. As the inverse distance increased, our capacitance linearly increased. This highly linear best fit line perfectly verifies our theoretical formula, showing an inverse relationship between capacitance and distance. We observed a percentage error of 132.66%. Moving on to graph 2, we analyzed how changing the plate area affects capacitance while keeping the distance constant at 0.03 meters. You can clearly see on the graph, this forms a perfect linear relationship, successfully proving that capacitance is directly proportional to the surface area of the plates. For our third graph, we investigated the impact of dielectric constants. We measured the capacitance using air, a wooden block, plastic, and paper. If we look at the trend line drawn, we can see the expected directly proportional relationship between the dielectric constant and capacitance value. We found a percentage error of 78.88%. To summarize our discussion and conclusion, we successfully achieved our objective of verifying how geometry and dielectric materials affect capacitance. We proved the inverse relationship with distance and the direct relationship with area and dielectric constants. Although we faced high percentage errors, these were not random. They were caused by clear systematic physical limitations of our microscopic setup. Finally, fringe effects at the edges of our small square plates also cause slightly higher charge storage than theoretical formulas predict. Despite this equipment and environmental limitations, our experimental hypotheses were successfully verified.